just to make sure everybody's on the same page. All right, so we're going to graph these. We're going to talk about vertex form. We're going to get into this equation on the board, how to get it converted into that. That's going to be the key today where completing the square comes into play. Max and min values, that's nothing different from last chapter. We did maximum and minimum last chapter. You did it on your test yesterday and you rock starred it. So more of the same. Modeling, of course, just means a word problem, okay? But it's still going to involve a parabola. So this looks crazy. Don't let that scare you. Just some long word stuff for a polynomial function. So polynomial function, it is a function that's defined in a polynomial expression. Okay, let's recall what polynomials are, vocabulary. So a polynomial is a sum of a monomial and multiple monomials. Now what's a monomial? Monomial, of course, is one term, mono, one. So you have a number times a variable. So like 5x squared is a monomial. 2x cubed is a monomial. So when you have a sum of them, polynomial. Okay, we are going to focus on degree of 2 today. Highest exponents 2 are quadratic functions. We will get into some specific things about third degree, fourth degrees as the chapter goes on. So quadratic functions, of course, this is what we're looking at with the squared is the key. Now, we've seen parabolas. We know how parabolas look. We got it. Now, two different forms of parabolas we're going to focus on. My favorite form, vertex form, and you'll see why. And then we're going to talk about standard form. Here's why I like vertex form. You can get a lot of information off the equation with no work, which I'm all about that, right? So here's why I like it. You can look at that equation and I can tell you what the vertex is of the parabola without doing a thing. To get the vertex, whatever number's in parentheses, they're using h there, in parentheses with x, you just switch the signs. So they have minus h, I'm going to put positive h. And then the number at the back is your y coordinate of the vertex. So you don't even have to do anything. Now, I also can tell you some other good fun-filled information. Your parabola is going to open up if a is positive, which we know that if the lead coefficient's positive, the parabola opens up. It's going to open down if a is negative. Let's talk axis of symmetry. So picture, oh, that's not too bad of a drawn parabola today, I'll take that. Picture your parabola. Of course, your parabola is symmetric, meaning there's this very lovely vertical line that would go through the middle and you fold it over and it matches up. So our axis of symmetry is going to be a vertical line. All vertical lines, x equals. And it goes through the vertex. So kind of a 2 for the price of 1. Whatever your x coordinate is on your vertex, that is also what your equation will be for your axis of symmetry. Now, we will, not for a while, also talk about how to graph parabolas that open sideways. Clearly that's a little more involved, but we will get into those in a chapter further down the road. Okay, other things that are important about your parabola, the width. Again, back to last chapter, whether you have a vertical stretch or a vertical shrink, that affects your width. So A also determines the width of the parabola. So let's say the graph is wider. So it widens out at 0 less than A less than 1. So if A is between 0 or 1, so that is really, just to get fancy, your vertical shrink. It widens out your parabola. So let's say you had 2/3 x squared. 2/3 is between 0 and 1. It makes it wider than your original parent function of a 1x squared. And of course, on the opposite, the graph is narrower or skinnier, if you want to put that, if A is greater than 1. So that, of course, is your vertical, not 0, I said 1 and I just didn't write it. That, of course, is your vertical stretch. So that's why I like this vertex form. I can get a truckload of information out of it without really doing any work. I can get you the vertex, I can get you the axis of symmetry, I can tell you it opens, I can tell you wide, narrow, all sorts of good stuff. And then, of course, I could draw it relatively easily. So the trick is when they don't give it to you in vertex form. So first example here, f of x equal 2x squared minus 12x plus 13. Express it in vertex form. So this is where we're going to do a little bit of work. We have to get that quantity squared. So we're completing the square. This is a throwback to the first chapter. So first thing I'm going to do, f of x, I'm just going to rewrite that as y. Just easier to write. You could keep it f of x, but just a little less writing for me. And I'm going to subtract 13 over here to get it out of the way. Now, when you complete the square, it's been a while since we've done it, your lead coefficient has to be a 1. Ours is 2. You're welcome. So our choice is, you got a choice. You can divide everything by 2, which wouldn't be a bad move on the right side. I'm like, oh man, if I divide 13 by 2, fraction. Y over 2 seems weird, okay? So my other choice is I'm just going to factor a 2 out. I'm going to use it as a greatest common factor over there. So I'm going to pull 2 out. So 2 times 6 is 12. Right? Okay. Now, notice I didn't close up my parenthesis. Here's why. We are going to add a lovely little blank here because I'm going to complete the square on 6x. Now, purpose of completing the square, it forces your trinomial to factor. The original problem doesn't factor. Even if you try to factor it, it doesn't factor. We're forcing it to factor. Now, review of how to complete the square. You're going to do half of b, which you can do in your head. Half of our b is 6, half of 6. And I'm going to square it. So 3 squared, 9. Okay. I do not expect you to write all of that out. Of course, you can do that little mental math. So half of b squared. Notice too, on purpose, I just did half of 6 instead of negative 6. Because remember, you square anything, it kicks into a positive. So I don't worry about the sign. I just do half of the number and I square it. Now, I can't just throw a plus 9 over there and not balance it on this side. I can't change the equation. So I'm going to balance it. I'm going to be conscientious. I actually didn't put 9 on that side. Realistically, I put what number? 18, because you have your distributor. I really put an 18 over there. So that's your distributor. All right, let's total up negative 13 and 18. That's just a 5, or 2. And the entire key purpose of putting that blue 9 on. This trinomial now factors. What multiplies to 9 and adds to negative 6? Negative 3 but I'm not going to go x minus 3, x minus 3. I'm going to write it quantity squared. And the last thing to get it to the vertex form, I'm just going to move the 5 back over so I'm in a y equals style. So I'm going to put y equals 2x minus 3 squared, and let's subtract 5 off the back. So that's the most amount of work you're going to have to do today is the completing the square work. That's why we did all that good stuff in chapter 1. Completing the square just comes up when you least expect it. Now, nice thing about it, I can tell you the vertex of it. We can get some other info from it. Let's do the vertex. So, vertex. Anytime you're in parentheses, you're going to switch the sign. So I'm going to put positive 3, and then you just steal the number at the back. Got it. Now we're going to do some intercepts, it says. Okay, we can do intercepts. Let's just go in order. So anytime you're on the x-axis, y is what? 0. So I'm just going to replace y with 0, and I'm going to go through and solve this, which I'm like, oh gosh, I got some computation due, but whatever. We'll make it work. So I need to solve that blue equation now for x. So I'm just going to use inverse operations. I'm going to add 5. I'm going to get rid of the 2. I'm going to cancel the squaring, so on and so forth. Let's add 5 over. But it's always the x-intercepts that are time-consuming. I'm going to divide 2. So I'm going to leave it 5 halves. I'm going to get rid of the squaring next. What cancels squaring? Square root. Oh boy, okay. Don't forget plus or minus, plus or minus. I say oh boy because I'm like, we technically have a radical in our denominator, so I have to rationalize the denominator now. This is like the ongoing problem that never ends here. We can't have square root of 2 in the bottom. So I'm thinking about, okay, I'm going to rationalize it, so I would need a square root of 2 and a square root of 2. Good Lord. Okay, so plus or minus. 5 times 2, I'm going to make it square root of 10. 2 times 2, square root of 4. Ay, ay, ay. And last but not least, I'm going to add 3 over. That's brutal, but I kind of love it. Now, when I write my x-intercepts, remember, ordered pairs. So this is my answer for x. We put 0 in for y. I was going to leave the door open so it'd be cooler, but this is already split up, so they're going to go out over there, and I'm going to close the door. I don't know what's going on. I just heard bad language too over there. Okay, moving on. Whew! I feel like I need a break now. We got it. So this is the most time-consuming part of the lesson. Is it hard? No, but it's time-consuming. And we're still not done, because it also wants y-intercept. Now, y-intercept, I know you're probably running out of room. It's okay, you really don't need any room. You can do the y-intercept in your head. If you're on the y-axis, what's x? 0. I don't know about you, I can put 0 in here, mental math it pretty easily, or even quicker. Your original equation, these are the same equivalent equations, just different styles, like 2/4, 1/2, same thing. If you put 0 in this one, for x, I mean, I can way do that in my head. What's your y-intercept? 13. If you put 0 in here, you'll get 13, okay? So the only redeeming quality about that original equation is called standard form. We're going to write it down here in a minute. The only redeeming thing I like about standard form, it's easy to get the y-intercept. It's always that third term. Otherwise, it's not all that useful. Vertex form is going to be easier when we start drawing it, graphing it, etc. All right, good stuff, because that's our next mission is to graph it. So I'm going to click it back here. So I'm going to plot my vertex, of course. I'm going to plot 3, -5. Start with that. 3, -5. Got it. I'm just going to click it back so the equation's in front of us. Just for fun, how's it going to open, up or down? I know it doesn't ask you, but just humor me. +2, so it's going to open up. Now, your x-intercepts. Can I graph that? Do I know what 3 plus or minus square root of 10 over 2, like where that's going to be? That's not very helpful for me drawing my graphs since they're in radical form. So I'm like, swell. So let's say I'm not using my calculator. I'm going hardcore. Always hardcore. I'm just going to make a quick little t-chart. So my vertex was at 3, -5. I'm just going to pick numbers on either side of 3, like 2 and 4, because it's symmetric. You'll get the same answers. So who cares if we put the 2 in or the 4 in? So I'm just going to click it back a slide and do a little bit of mental math here. Now I'm going to put 4 in here for x. I'm going to put 4 in. That just seems easier to me. 4 minus 3, 1, squared, 1, times 2, 2, 2 minus 5. I'm going to plot those, of course. 2, -3, and 3, -5, and 4, -3. Got it. Now, is that enough to draw the parabola? Probably. I could probably sketch it. But we know my drawing skills, or, well, lack of. I'm going to do 1 and 5 just for another set of points. Can you get these off your graphing calculator? Sure, but we're hardcore. I'm going to put the 5 in. 5 minus 3, 2, squared, 4. 4 times 2, 8. 8 minus 5, 3. We know my lack of drawing skills. So 1, 3, got it, 5, 3. So this is why, if you look at where it hits the x-axis, and pretend I could draw, you can see, of course, that it does not hit your x-axis at nice whole numbers. That's why we had those crazy radicals. I know it doesn't ask us for it, but I just can't help myself. I'm going to also throw my axis of symmetry on right here through the middle. So it looks nice. I just like it to look pretty and have the axis of symmetry on there for fun. All right, find the domain and range of the graph. Well, we can do that easy enough. Let's do domain. So, as always, 2 ways to do the domain. You can either look at the graph, how far left, how far right does it cover, or Are there any restrictions on either version of the equation of what you can put in for x and square it? No, I can square anything my little heart desires. Positives, negatives, 0, whatever. The domain of all parabolas is all real numbers. You can put in anything and square it. Your range, of course, will change. So range, lowest to highest. My lowest point right there at -5, and then we're above it. So you could write an inequality. Y is greater than or equal to -5. I'm feeling fancy, I'm going to go interval notation. Or you can do your all real numbers. Either version, as always. So nothing new or different on domain and range. The worst part, the time-consuming part, is the completing the square to get it into the vertex form. All right, let's talk max and min. You did max and min last chapter. There's nothing new or wild or exciting about it. Guess what? This graph, if it opens up, has a minimum. I can tell you that is the minimum point. If it opens down, it'll have a maximum. So let's just kind of summarize this. The function has a maximum if the parabola opens down. Function has a minimum if it opens up. Got it? And just notice, okay, where they're at the y coordinate, because that's your lowest or your highest point. That's why they have that, of the vertex. So, for instance, I'm going to click it back to this picture. If I asked you minimum, we've got a minimum, my minimum value is -5. The lowest number on this graph is -5, the y coordinate of the vertex. So nothing exciting, you know that. All right, more graphs, more exciting. Oh good, vertex form, great, we get to complete the square again, get excited for it. Okay, so that's the key part of this. Consider the quadratic function. Those are some nice big numbers. I'm pretty excited with 49 in there. Express it in vertex form. Okay, so even if I tried, that won't factor. I'm telling you it's not going to factor. So we're going to complete the square. First, I'm going to rewrite f of x as y. Just left to right. You could keep it f of x, but you know, I'm going to subtract 49. Now, when you complete your square, the coefficient should be a 1. I'm going to have to factor that 5 out. You could divide by 5, but it gets fractiony. I'm not sure fractiony is the word. 5 times 6 is 30. Okay, let's complete the square in our head. So half of 6, 3 squared, 9. Now I can't just put a +9 on one side, I got to balance and do the other. But I'm going to be careful. I'm not just going to slap a +9 on the left, because I really put what number over there? 45, yeah. So don't forget about your distributor in the front of that. Okay, I'm going to total up -49 and 5. I'm going to factor that trinomial on the right side, multiply the 9, add to -6, got it. And last but not least, I'm just going to add 4 to the very back of it. Okay, and if you want to write y back as f of x, you can. Whenever I have to, I see the graph grid, whenever I have to graph, I like it as y for my coordinates. So find the minimum. Well, let's sketch the graph and do the minimum. Now, sketch the graph, it doesn't ask us for a ton of stuff, which is kind of nice. Vertex, I can give you that. We should know the vertex and plot it. Remember, switch the sign on the value with parentheses. So I'm going to put +3, steal the number from the back. Got it. 3, 1, 2, 3. I know it doesn't ask, but we should recognize our parabola is going to open up, +5. And I'm just going to make a quick little t-chart. I'm not going to get carried away. I'm just going to put numbers in on either side of 3, so like I'm going to use 2 and 4. Now, you could plug those into the original equation. I feel like that's going to be a lot of calculating though. I think I can do our vertex form quicker in my head. So I'm going to put 4 in here for x. 4 minus 3, 1. Squared, 1. 1 times 5, 5. 5 plus 4, 9. Let's just plot those and get it drawn. 2, 9, and then 4, 9. I couldn't fit another pair of points even if I wanted to. Pretty skinny, which I'm not surprised because you have your vertical stretch by a factor of 5. And I just like to draw my asymptote on there. I don't know, I just do have it. Okay. Find the minimum value. Minimum. What is the lowest point on the graph? And specifically the y coordinate of that point, because we want low. Final answer for your minimum. 4. The y coordinate of your vertex. The completing the square obviously is the time consuming. After that, it's not so bad. All right, consider, more completing the square. Here we go. This is going to be a good one. I like this one. Consider the quadratic function, express in vertex form, determine the opening, determine max or min. That part will be easy. Let's get it in vertex form. I'm going to subtract 2 over. Okay. Same spiel as always. To complete the square, your lead coefficient needs to be a positive 1. You have a negative 1. You could switch all the signs. That's totally fine. You're still going to have to deal with the negative at the end. I'm just going to leave it where it is, and I'm just going to factor out a negative 1. Negative 1 times negative x. Now, this is going to be fun because we're going to have some fractions. Some of you, hopefully, can do it in your head. Half a b. What's half a 1? Half a 1. 1/2. Here we go. What's 1/2 squared? 1/4. That's nice. Nice. Got to do a fraction, but notice we're not graphing the one with the fraction in it. Okay. All right. Now, careful. I didn't just put 1/4 over there. I technically put negative 1/4 over there. Be glad we don't have to graph. Okay. All right. Negative 2 plus negative 1/4. Well, I'm not going to get stressed. I'm just going to make it negative 2 and 1/4. Okay, your right trinomial factors. If you're like, dear Lord, what multiplies to 1/4 and adds to negative 1? Well, maybe, I was going to say no judgment on the fraction skills, maybe a little patterns, my friends. When you did half a negative 6, it's negative 3. That's always the pattern when you factor completing the square. So half of negative 1, negative 1/2. And I'm going to add the 2 1/4 to the back and be done with it. And again, I'm very glad I don't have to graph it. Okay. Determine direction or opening. Okay, we got it. So opening, let's do that. So I'm just asking you, does it open up or down? Down. Your lead coefficient's negative. And determine the maximum or minimum value. Well, next question for you. If it opens down, does it have a max or a min? Does it have both? Which would it have if it opens down? Max. Max. And remember, that occurs at the y coordinate of the vertex. What's your y coordinate of the vertex? 2 1/4. Super happy I don't have to graph that. Okay. So again, the most time-consuming part is the completing the square. Not that it's awful, but time-consuming. All right, let's talk about standard form. Just our traditional trinomial style, meaning your squared term, then the number, of course, and then the third term at the end. Now, standard form is probably my least favorite because you don't get as much information from it. The only thing I like about standard form, I can tell you the y-intercept just from looking at it. It's always going to be that third term, whatever c is. That's the only thing I really like about it. Otherwise, I find it a little not that useful, not that helpful. But you can find the x-coordinate of the vertex when you're in standard form. The calculation for that is opposite of b over 2a. Hopefully that looks a little familiar to you. A little 8th grade math there. So opposite of the middle number over 2 times a. That gives you the x-coordinate. Now if you know the x-coordinate, let's say you calculate that, you get 10. If I know x, I can get you y. I'm just going to substitute 10 into my equation. So to find the y-coordinate, you're going to substitute, I should have left a longer blank, I guess, the x-coordinate in the equation. So if you get 5, put a 5 in for x and calculate it out. Axis of symmetry goes through that x-coordinate, which is that opposite of b over 2a. So you don't get quite as much info off of it, but you will see some equations given in standard form. So that's our next thing. We're going to do a little standard form. So find the max or min of each quadratic in standard form. Okay, fine. Now, at first I'm like, oh, God, I got to complete the square. Then I'm like, no. We don't have to go through all of that. We are in standard form. It doesn't tell me I got to put it in vertex form, so I can just use my opposite of b over 2a to get that vertex. So little calculations. Opposite of b is 4, so we're going to put -4, 2 times a. And do that in our heads, -4 over 2. Now remember, that is your x coordinate. When we want max or min, I'm after the y coordinate from you. So big deal, you probably can still do this in your head. You're just going to replace these x's with -2. So I'm going to have -2 squared, 4 times -2. Got it. I'm just going to total that up. Okay, so final answer. Let's get it. A couple questions for you. First question, how would this parabola open? Up or down? Up. So does it have a max or a min? Min. It has that lowest point. And specifically, what value is the minimum? The y value, -4. And my final answer. Because you're going to have your parabola that opens up, so a min. Okay, so, I mean, that's not awful, I think, a little calculating. Same thing, I'm in standard form. Doesn't say have to convert, so I'm just using my opposite of b over 2a. So opposite of b, 2 times a is -2. So I have -4 over -4. That's your x coordinate. You, my friends, we're going to replace all the x's now with 1 to get the y. So if we put 1 in here, so 1 squared times -2, 4 times 1. So I'm going to have 2 minus 5. Okay, so let's get a final answer for this guy. First question, how would that parabola open, up or down? Down. So max or min? Max. And of course, the y coordinate, -3. Got it. So homework starts out time consuming to do the vertex form, but then you kind of get tossed a bone here. It gets kind of easy for you. You can just do some calculations. And it wouldn't be a day if we don't do a word problem. Hockey team plays in an arena that has a seating capacity of 15,000 spectators. With the ticket price set at $14, average attendance at recent games has been 9,500. A survey indicates that for each dollar, the price is lowered. So right away, I'm thinking subtracting, lowered. The average attendance, oh, God, that's good, increases by 1,000. Find a function that models the revenue in terms of the price. Okay, so revenue. How much money we're making selling these tickets to the hockey game. So I'm just going to do revenue. So I'm just trying to get a game plan. If I'm going to figure out how much money I'm going to make selling tickets to the hockey game, of course, okay, it's going to be my price of the tickets. So my $14, I'm thinking about that, times however many people show up. I'm just going to put attendance. So if tickets are $20 and 500 people show up, whatever, 20 times 500 be your revenue. Well, let's get specific here. So we are trying to figure out our ticket price. So that's going to be my variable. I'm going to call that x. And just because I don't want that to look confusing with the multiplication symbol, I'm going to switch it to a dot there. I want it to look like I have two x's next to each other. That seems confusing. Now here is the fun part, the attendance. So let's reread this. With the ticket price set at $14, average attendance has been 9,500. So I'm going to start with the 9,500. But it increases by 1,000 for every dollar it's lowered. The price is lowered. And we're starting at, of course, the $14. So more parentheses, I'm starting at my price of 14, and for each dollar, that's a one on specific dramatic emphasis, our attendance is changing. That looks crazy to me, crazy, but it's really not going to be that bad once we distribute, simplify, all that sort of good stuff. So just our price of the tickets we're trying to figure out, our average attendance starts at 9,500, increases by 1,000 for every dollar we decrease our price. Whew. Okay, I already hear calculators clicking. Let's start distributing, doing all our good stuff. So I'm going to run 1,000 through there, of course. 1,000 times that, 14,000. 1,000 times x, 1,000x. I need longer arms. Keep distributing, combining your like terms. I'm going to trust for the sake of time, and it's so hot in here, you guys look like you're melting. I am too. I'm just going to give you a final simplified answer here. Okay, so there's my expression. I've seen your wonderful algebra skills. I know you can distribute and combine like terms. It's the least of my worries. So let me give everybody a chance to actually have it written down. Because then we have to figure out, find the price that maximizes the revenue from the ticket sales. Okay, let's do that next. Now, and that's going to be on my next slide because I can't fit it all in one. First quick question for you. Squared, so it's a parabola. Is your parabola opening up or down? Down, right? So the next question, which is on my next slide here, maximum. So this is a very long, wordy, winded way to say, hey, I need you to find the vertex of the parabola. Okay, cool. I'm in standard form. I'm not putting that in vertex. I am not completing the square. You're out of your mind if you think I am. It doesn't say we have to. So I'm just going to go old school and use that opposite of B over to A to get my vertex, which I'm going to do on the next slide because I'm out of room over here. So I'm going to do opposite of B over to A. So I'm going to have opposite of B, so negative 23,500 over 2 times A. A was a negative 1,000. Okay. So I punched that in, and I just rounded to do decimal places. I get this. So that is your x coordinate. That is what we're after right now, the price of the tickets. I'm just going to throw a dollar symbol on it so it looks like a price. Got it. Didn't ask me for y, didn't ask for the actual revenue, just wanted the price of the ticket. That's why I'm not plugging it in. It didn't ask me for the revenue. Okay, let's see what this, what ticket price is so high that nobody attends, so no revenue is generated? Okay, let's go back to this. So if we have, I'm going to give it away, 0 revenue. I'm going to take my green equation and replace the r with 0, and I'm going to try to solve it, which will be fun. So I'm going to do 0 equals my very lovely equation. As you can see, I got to look at my notes here because I can't remember all these numbers off the top of my head. Now I'm looking at that and I'm like, oh my gosh, I got to solve for x. First question, how many answers for x are you going to get? 2. Next question, those are some super big numbers. I would try to reduce it down. What could you divide by to make it a little easier on yourself? We could do 2. I'd try to go bigger. I'd try to go bigger than 2. Bigger than 4, Owen. Big. Elliot?
100.
You could do 100? I mean, I'm going bigger. Mason? I'm going to go 1,000. I don't want to work on those big numbers. We don't have that time. It's hot in here. Gosh, okay? So, let's divide by 1,000. Now, you could do positive 1,000, negative 1,000. It doesn't matter. Usually, because I'm hoping I can factor on this. I do not want to use quadratic formula. I'm hoping I can factor something. So I'm going to divide by negative 1,000 so my lead coefficient is positive, make my life a little easier. So I'm going to, if I divide by negative 1,000. Okay, so I'm going to make it x squared. Don't let this scare you. What's 23,500 divided by 1,000? You can use your calculator.
Negative 23.5.
Thank you. Now you're like, oh my gosh, a decimal, that's so awful. And I'm like, no, it's not. Because remember I said, I'm gonna try to factor on it. I'm not scared of a decimal answer, because I mean, $11.75 decimals, it's gonna happen here. I can factor on that super fast. What can I take out of each of those? X. We are almost done. What are your, get ready for this, 2 potential answers for X? Yeah. And notice I very dramatically said potential, because which one does not make sense for this problem? The 0, because they're asking you what ticket price is so high. You're going to have a ticket price of 0. Okay, so we're going to put $23.50, put a little dollar sign, would be our final ticket price. It's too high. Nobody's coming at $23.50. I wouldn't go anywhere. I don't know what I'd pay $23.50 for. That is a lot of money. Okay, any questions on that? Whew, it's so hot.